2 4s on dividing positive and negative fraction. It's going to be very comparable to yesterday's lesson. Yesterday's lesson was multiplication with positive and negative fractions. Big thing in terminology that they'll use here today in our book is called the multiplicative inverse. You've probably heard to it referred to as the reciprocal. Means the same thing. A generic definition they'd give you in the back of the book would be two numbers with a product of 1. So basically when you multiply them together, you get 1. Example of a reciprocal would be this: 3/4. The reciprocal to 3/4 would be 4/3. Now if you had a negative number, let's say, we'll say -2. Well, you can make -2 a fraction. Well, it would be -2 over 1. The reciprocal of -2 over 1 is -1/2. Notice how your numerator and denominator just switch places there. To divide fractions, here's the big concept. To divide fractions, you're going to multiply by the multiplicative inverse, okay? And again, you're dividing, but it says to multiply. Well, you're multiplying by the multiplicative inverse. So if you look at the first example here, we have 2/5 divided by -3/4. We don't want, it's whatever you're dividing by. We don't want to divide. So what you're going to do, and if you look at this next step here, instead of dividing, you're going to multiply by the inverse. Okay, so 3/4 in this first scenario, we're dividing by 3/4. Don't divide, multiply by the multiplicative inverse. And then you follow your concepts of multiplication. First example here, we have 2/7 divided by -8/9. Divide by -8/9. We don't want to do that. I'll go ahead and I'll let you write down 2/7 divided by -8/9 on your paper there. Now, instead of dividing, this is what I'd expect you to see on the homework, is 2 divided by 7 multiplied by a negative, okay, it still stays negative fraction. We're going to multiply by the multiplicative inverse or a reciprocal, which would be 9/8. Now you can go ahead and continue by reducing your problem. Well, we can reduce diagonally here. 2 can go into 2 and 8, 1 time, 4 times. We get a fraction, a negative fraction, because we're multiplying a positive by a negative, and we wind up with -9/28. Next example, -3/5 divided by 9/10. Here we're going to again start out with -3/5. We don't divide, we multiply, and we multiply by the inverse. The inverse here would be 10/9. Again, go ahead and do your reducing. Well, I can reduce here. A 3 can go into 3 once, a 3 can go into 9 3 times. A 5 can go into 5 once, and a 5 can go into 5 2 times. Now if you look here, we have that first fraction is negative. Negative times a positive is a negative outcome. Multiply your numerators and denominators, and we get a -2/3. Example 3. Remember we talked about anytime we have a mixed number, we need to go ahead and convert into an improper fraction. And in order to do this, we multiply and add. So we have 4 times 3 plus 1 gives us 13/4 divided by, multiply, add. I'm just going to go ahead and drop the negative sign down. And when I do this, I have 8 times 2 is 16 plus 1 is 17/8. Now that I've converted, the next step that I want to do is get rid of that division. Again, we don't want to divide, we want to multiply. So I'm going to multiply by a negative fraction, and I multiply by the multiplicative inverse or reciprocal. So there's my new problem, 13/4 multiplied by a -8/17. So positive times a negative is a negative outcome. I look to reduce within my problem, and I can diagonally. A 4 goes into 4 once, into 8 twice. Do your multiplication, and I get 26/17. So -26/17. Example 4, I want you to go ahead, write it down, 2 1/3 divided by negative 1 1/9. Pause the video right now and then give a shot on your own, and then when you finish, bring it back up and we'll work through it. So our first step, we should have gone and converted our mixed numbers into improper fractions here. So we should have 7/3 divided by negative 9/10. Next, get rid of that division. And we're multiplying by that multiplicative inverse. Reduce within your problem. After you reduce within your problem, go ahead and do your computation. So we have a negative outcome here. And our numerator is 21, our denominator is 10. Kind of a realistic example here. Movies one summer day. A cinema shows a hit action movie repeatedly for 12.5 hours. It takes about 150 minutes to run the movie and prepare for the next showing. How many times does a cinema show the movie that day? First thing that we'd want to do here is do a little conversion here. Right now you have 12.5 hours, and the other you have 150 minutes. So you either need to convert to hours or minutes. Personally, I'd rather go ahead and convert into hours. So I need to do my conversion here, and I need to convert 150 minutes to hours. In order to do that, I know that I'm dealing with 150 minutes, and I know that there are 60 minutes in an hour. So I do my conversion. 150 minutes divided by 60 minutes. I have a fraction there, and then I can go ahead and reduce that fraction. When I reduce that fraction, I would actually wind up with 5 halves. Okay, 5 halves is basically 2.5 hours. So there's your conversion right there. Now we're kind of comparing apples to apples here. We have hours and we have hours. So our movie theater here runs the movie repeatedly for 12.5 hours. So 12.5 hours, it runs it repeatedly. We want to figure out how many times we can play it if it takes 150 minutes, also known as 2.5 hours. Okay, so basically we want to figure out how many 2.5 hour shows fit in this 12.5 hours. So we would divide by 2.5. Next thing I would do is I would go ahead and do my conversion here. This would be 25 halves divided by, well, we know this is 5 halves. Next step is, instead of dividing, we want to multiply. So we don't want to divide by 5 halves. Instead, we multiply by the multiplicative inverse, which is 2/5. Now we can look to reduce within our problem here. Our 2's now become 1's. 5 and 25, well, 5 can go into 5 one time, and a 5 can go into 5 5 times. Do your multiplication, and we wind up with 5 over 1, which equals 5 shows. So they can fit 5 shows in that allotted time. Last example, zoos. A zoo has a reptile show that runs repeatedly for 10.5 hours. It takes about 105 minutes to conduct a show and prepare for the next one. How many times does the zoo run the reptile show each day? Again, you have 10.5 hours, 105 minutes. Well, we need to do some conversions here. We're comparing the apples to oranges here. So let's convert 105 minutes into hours. So we know there's 105 minutes, and there's 60 minutes in 1 hour. So we're doing our conversion of minutes to hours, and we have, after we reduce here, we would wind up with 7/4, also known as 1 3/4. So 1 3/4, 1 3/4 hours. We want to figure out how many times this reptile show runs in 10.5 hours. So 10.5 hours divided by our 105 minutes, which we converted to 1 3/4 hours, basically. Now we can go ahead and do our conversion. We wind up with 21 halves divided by 7/4. Instead of dividing, we multiply by the reciprocal. So we have 21 halves multiplied by 4/7. Reduce within your problem, and we can reduce the 7 and the 21, and we have 6/1, which would be 6, again, shows. You could run 6 shows in that amount of time. We have a little reptile video for you on this big snake here, so I'll show you here. This will conclude our lecture on 2-4 dividing positive and negative fractions.